of the function f of x is equal to log of under root of minus greatest integer of x with base greatest integer of x. According to base change theorem, log of a with base b is equal to log of a with base c whole divided by log of b with base c. Applying this property in this function here, I can write fx as log of under root of minus of greatest integer of x with base e whole divided by log of greatest integer of x with base e. We can choose any base here, so I'll choose e, which is the Euler number. Now for log to be defined, input of the log function should be positive. That means for log of under root of minus greatest integer of x with base e, this input should be positive, which implies under root of minus of greatest integer of x should be greater than 0. Only then this log function would be defined. Squaring both sides, minus greatest integer of x should be greater than 0. Now multiplying both sides by minus, so it becomes greatest integer of x is less than 0. On multiplying, the inequality changes sign. Now let it be equation number A. Similarly, for log of greatest integer of x with base e, this input of the log should be positive, which implies greatest integer of x should be greater than 0. Let it be equation B. From equation A, greatest integer of x is less than 0, and from equation B, greatest integer of x is greater than 0. And for f of x to be defined, we must have common values for equation A and B. That means we should take the intersection of both the cases. But after looking the equations, we can say no such real value of x exists where greatest integer of x is less than 0 and greatest integer of x is greater than 0. Therefore, domain of fx is equal to phi. So if the domain is phi, range of the function is also phi.